In this problem, we need to find the zeros of the polynomial function f of x equals negative 3x to the fourth times x plus 7 times x minus 2 all squared, and then we have to state the multiplicity of each zero. Well, how do we find zeros of any function? We set the function equal to 0. So I'm going to take this expression and set it equal to 0. So I have negative 3x to the fourth times x plus 7 times x minus 2 all squared equals 0. Using the zero product principle, we set each factor equal to 0. Remember, negative 3 can't equal 0, so we're going to set x to the fourth equal to 0, x plus 7 equal to 0, and x minus 2 all squared equal to 0. Then we solve these little equations. X to the fourth equals 0 when x equals 0. X plus 7 equals 0 when x equals negative 7. All I did was subtract 7 from both sides. X minus 2 all squared equals 0 when x minus 2 equals 0. Adding 2 to both sides, I get x equals 2. Now we've found the zeros, all we have to do is find the multiplicity. So let's look at multiplicity. Let f of x be a polynomial function whose equation is in factored form. If the factor x minus c appears exactly k times, notice exactly k times, then we say that c is a zero with multiplicity k. So our first zero was x equals 0. It came from the x to the fourth term in my polynomial. And how many times does x occur in the x to the fourth term? It occurs 4 times, so my multiplicity for x equals 0 is 4. My next zero was x equals negative 7. It came from the factor x plus 7. And how many times did x plus 7, the factor, occur in my polynomial? Well, remember, there's a little invisible 1 on that x plus 7 that we're too efficient to write. So x plus 7 just occurred 1 time in my polynomial, so the multiplicity of x equals negative 7 was 1. My last zero was x equals 2. It came from x minus 2 all squared. How many times does the factor x minus 2 occur in my polynomial? Well, it's the exponent. It's 2 times. So my multiplicity of x equals 2 is 2. So there are all the zeros with their multiplicities.